Okay, what I want to show you today is from the last video. I've added a big capacitor bank that I got salvaged from an old solar inverter and a 24 volt motor. What I want to show you is the input we have is a 12 volt DC input. I've taken the other section of this off just to show that this is the section that will be probably charging itself, and then the next section will be that was what we'll be focusing on. This section is what we'll be focusing on to power the lighting. So this will be a self-running section whilst having this kind of setup powering the lighting. I just want to show you something here. So from the 12 volt we can run this, and there's enough power in this piston, if you like, to fill up the reservoir while this is running. So this is drawing 24 volts off to run itself at maximum, but we're still increasing from the 12 volt. I'll just show you. So we start it up. You see we have an increase. And we're still collecting power. Turn it down a little bit. As you can see, we have constant spark. Turn it up again. It's a really fast capacitor charge. This on its own would be enough to run the inverter grid tie, depending on how much is sucked out of this battery. It is minimal because we're using the pulse width modulator. So I'll turn it down, I'll turn her off, and just explain the setup. There's a drawing if you take a still. So we have 12 volt battery input, pulse width modulator, ZVS driver, through into the flyback transformer, one side going out to an earth, the other side coming out through diode, spark gap diode, and then into the earth. This side is the toroid, the ferrite ring with a bifilar winding. One side goes directly, which is the negative, excuse me. The other two go through two caps at 160 volts each, 100 microfarad, only through the positive side, through into two Schottky diodes, and both into the positive side of a capacitor at 50 volts, 100,000 microfarad. They go then into this capacitor bank, 6 by 500 volts, 470 microfarad, and then into the 24 volt DC motor. So what we're working on is step 2, which should be being able to find out the balance between what's being used on the input and what we make on the output. It could also be that we use this only with an inverter, and also connect with this, so we split the amount of DC used. Again, that's something we're playing with at the moment. So I'll just give you an aerial shot of what it is. So we have 12 volt pulse width modulator, ZVS, flyback driver. Yeah, this is the toroid there, going out through 200 volt caps, Schottky diodes, 50 volt capacitor, capacitor bank here, 24 volt motor. Other side from the flyback, going out diode, spark, out through this is just holding it out through one earth, and this is not connected, out through the other side through an earth. So I'd like some input, gentlemen, ladies, as to what you think the next move is. If we have something here that can be played with. Please comment.